In the previous video, we have seen the representation of a given signal in the general form for a representation of a given signal in trigonometric Fourier series. Now we'll look at a few problems, how to represent a given signal in the form of trigonometric Fourier series. If you look at the first problem, the given signal is shown here. So now we have to identify if it exhibits any symmetries. Right? If you look at this waveform, does it exhibit any symmetries? Let us take x of minus t. X of t is given. We'll draw x of minus t. What is x of minus t? How does it look? X of minus t looks like a folded version, right? So how will it look? It looks very similar to what is our x of t, right? X of minus t looks similar to x of t. At x of 0, x of minus 0 is also a, right? So a, and x of t by 2 is as same as x of minus t by 2, which is like this, right? This way. So this is my x of minus t, which is equal to x of t. When x of t is equal to x of minus t, what kind of symmetry it is? It is even symmetry, right? So the given signal exhibits even symmetry. So the given signal is an even signal. So we have found out one of the symmetry, that is the given signal is even symmetry. We should also see if there is any other symmetry that the signal exhibits. So let us check for half wave symmetry. If I have to look at half wave symmetry, what is the formula for half wave symmetry? F of t plus or minus t by 2, right? It must be equal to negative of f of t. So if I shift my original signal by half of the time period, here the time period is from this point to this point, right? This is the signal that is repeating, so the time period is t. So if I shift my x of t by half of my time period, that is t by 2, it should be equal to negative of f of t. So I am going to shift my x of t by t by 2. So whatever is there at 0, it should start at t by 2, right? So whatever is there at 0, it should start at t by 2. So it will be something like this, right? So which is exactly the opposite of x of minus t, f of minus t, right? So here we can say x of t plus or minus t by 2 is equal to minus of x of t. So which means it also exhibits half wave symmetry, right? It also exhibits half wave symmetry. Okay, it exhibits half wave symmetry. So first of all, what are the three coefficients we have to find for TFS or trigonometric Fourier series? For the first one is A0, the second one is AN, and the third one is BN, right? A0 and AN are for cos, so BN is for sine. Now we have already found the signal is even symmetry. It has even symmetry. It has even symmetry means A0 and AN will exist, Bn does not exist, so Bn goes to 0. Now A0, we have already found that the signal also shows half wave symmetry. What is the condition if we have half wave symmetry? What are the what will happen if we have half wave symmetry? If we have half wave symmetry, we'll only have odd harmonics. That is, for n is equal to odd number only, we'll have the harmonics. All the even harmonics will vanish, right? So A0 is an even harmonic. So this will vanish because of half wave symmetry. This will vanish. So this is also 0. And AN will exist only for n is equals to 1, 3, 5, and so on, odd harmonics. So if it is sufficient, if we can find AN, right? So what we'll write, we'll just write the given signal x of t exhibits even symmetry as well as half wave symmetry. Hence, A0 is 0 and Bn is 0. So we'll find AN. What is the formula for AN? The formula for AN for even signals, it is 4 by t integral 0 to t by 2 f of t cos n omega naught t dt. So let me write 4 by t 0 to t by 2 f of t cos n omega naught t dt. Okay, now my period here is, I can consider 0 to t, right? I can consider 0 to t. So what is my value from 0 to t by 4? 0 to t by 4 is a, and from t by 4 to 3t by 4 it is minus a, and again from 3t by 4 to t it is minus, it is plus a, right? So 4 by t, 4 by t, so I have to consider only till 0 to t by 2. So 0 to, the first interval will be t by 4, and in that value, in that interval, the value is a. A is a constant. Okay, a cos n omega naught t cos n omega naught t dt plus 4 by t integral t by 4 to t by 2, from t by 4 to t by 2, the value is minus a. So minus a cos n omega naught t dt. So let us simplify this. 4a by t, I'll take it common, right? So what is integration of cos n omega naught t? Integration of cos is sine. Integration of cos is sine. Sine n omega naught t by n omega naught by n omega naught with the limits 0, t by 2, sorry, t by 4. And again here there is 4a by t, which is common, and a negative sign. Integral of cos is again sine n omega naught t by n omega naught. Now the limits here are t by 4 and t by 2, right? 4a by t. So both of them have n omega naught in common. So I'll just take n omega naught outside. So into 1 by n. Omega naught can be written as 2 pi by t, right? 2 pi by t. Then sine, let me take another value here, right? Okay, sine n omega naught is 2 pi by t into t by 4. The upper limit is t by 4. That will be tt cancel, and we are left with n pi by 2, right? We are left with sine n pi by 2. Sine n pi by 2, and if you substitute 0, it is sine 0. So we don't have to write that. And minus, if you substitute t by 2 in place of t, it is n into 2 pi by t into t by 2 to t by 2. T cancel, 2 cancel, so we are left with n pi. Sine n pi is always 0. Sine n pi is always 0. So 0 minus sine t by 4. Sine n omega naught into again t by 4, which is same as this. So again sine n pi by 2, right? Sine n pi by 2. So that is equal to t and t gets cancelled. Here, if you add these two, you will get 2 sine n pi by 2, right? 2 sine n pi by 2. So 2 and 2 gets cancelled. So we are left with 4a by n pi, 4a by n pi sine 4a by n pi sine n pi by 2, right? 4a by n pi sine n pi by, that is my a n. So this is my a n. So now I have to write the x of t, given function x of t, in terms of trigonometric Fourier series. X of t, what is the formula of x of t? X of t is nothing but, the formula for x of t was what? A naught plus summation n is equals to 1 to infinity a n cos n omega naught t plus bn sin n omega naught t, right? A naught is 0, bn is 0, so we are left with only an. We are only left with an, right? We are only left with an. That also we are only left with odd harmonics, right? Only odd harmonics. N is equals to 1, 3, 5 and so on, right? Only odd harmonics, not even harmonics. 1, 3, 5 and so on. an cos n omega naught t, right? Cos n omega naught t. So if we'll just expand it, we'll just try and expand it. If we expand it, when n is equal to 1, when n is equal to 1, I have 4a by pi, 4a by pi. I have cos omega naught t. When n is equal to 3, I have 4a by 3 pi. So 4a by pi is common, so I have 3 in the denominator, and in the numerator I have cos n is equal to 3, so 3 omega naught t. Then for n is equal to 5, for n is equal to 5, I have cos 5 omega naught t divided by 5, and the magnitude again is 4a by pi common, and so on. So this is my representation of x of t in Fourier series, trigonometric Fourier series, right? That is the trigonometric Fourier series. Now if I have to represent the magnitude, I will draw the magnitude spectrum of my signal. Okay, let me draw the magnitude spectrum. Okay, the magnitude spectrum we'll see later after we see the second form of Fourier series, that is modified form of trigonometric Fourier series. Till then, this is your final answer. So what did we do in this problem? We have first taken the given signal and checked for symmetries. What kind of symmetries does it exhibit? Does it exhibit even symmetry or odd symmetry? And if it exhibits any half-wave symmetry. These are the three kinds of symmetries we check for. If it exhibits even symmetry, then Bn goes to 0. If it exhibits half wave symmetry, then only odd harmonics exist. So based on that, we have found out that it is sufficient to calculate An. So we took the formula for An, which is 4 by t, 0 to t by 2 f of t cos n omega naught t dt, and we substituted the values of f of t in the range 0 to t by 2, 0 to t by 2, and then we simplified and finally calculated the value of An. Then we know the trigonometric representation, trigonometric Fourier series representation of any given function as a naught plus summation 1 to infinity an cos n omega naught t plus bn sin n omega naught t. So in that formula, we have substituted an, a naught and bn were 0. After substituting an, we just expanded the given, we just expanded the summation for 3 different n values to get the final answer, right? Then let us see another problem. This time TFS for this signal. This is also called full wave rectifier. This is also called full wave rectifier. It is called full wave rectifier. So let us see if it exhibits any even symmetry. Does it exhibit any even symmetry or odd symmetry? So basically, if you fold or reverse the given signal, right, if you fold this signal on the x-axis, if you fold it around the y-axis, this right half of the y-axis overlaps with the left half, right? It is exactly overlapping this thing. When you fold it, it exactly overlaps with the left half. So it is an even signal. It is an even signal. It just looks like a mirror, right? It is a mirror image. The right half side is the mirror image of the left half side. So it exhibits even symmetry. And does it exhibit any other symmetry? Even symmetry is there, so it will not be odd. Then half wave symmetry. So the period here is t by 2, right? This is the part that is repeating again and again. So the period is t by 2. So if you shift the original signal by half of the period, what is half of period now? T by 4, right? Half of this period is t by 4. So if you shift this signal by t by 4, then how will your signal look like? The signal will look like this. So whatever is there at 0, it comes at t by 4. So it looks something like this, right? So is this negative of x of t? Is this negative of x of t? This is not equal to minus of x of t. So it does not exhibit half wave symmetry. So this is the only symmetry we have, even symmetry, right? That is the only symmetry we have. Then, so based on the symmetries we found, what do we have to find now? What are the coefficients we have to find? Since it is even symmetry, Bn is 0. So we have to find A0 and An. These two we have to find, right? So let us take A0. So what is the equation for x of t here? X of t. What is the equation for x of t? X of t is equal to sine. This is sine form, right? This is a sine signal, right? So x of t is equal to, the amplitude is a into sine t for t in between 0 and t by 2. So this is one period, right? This is the signal that is repeating. So we are only considering from 0 to t by 2. We are only considering from 0 to t by 2. So let us take A naught. A naught formula when the signals exhibit even symmetry is equal to 2 by t 0 to t by 2 0 to t by 2 f of t dt, right? Then so that is equal to 2 by t 2 by t x of t is nothing but a into sine omega t. So a is a constant. So 2a by t 0 to t by 2 0 to t by 2 sine omega naught t dt, right? That is equal to 2a by t. Integration of sine is minus cos omega naught t divided by omega naught limits 0 to t by 2, right? So minus 2a by t I will get omega naught outside, so it will be 2 pi by t and cos omega naught t. Cos omega naught t is equal to be, what is omega naught t? It is 2 pi by capital T into, in place of small t it is pi by 2, sorry, t by 2. So simplifying this we have pi. So cos omega naught t becomes cos pi. So cos pi is nothing but minus 1 minus cos 0. Cos 0 is 1, right? So 2 gets cancelled, and this is minus 2. Minus 2 into minus is plus 2. So 2a dt gets cancelled, divided by pi. That is my a naught. So likewise we'll find a n. Let us find a n. A n formula is 4 by t 0 to t by 2 x of t cos n omega naught t dt, right? In place of x of t we will substitute a sin omega naught t. So 4a by t integral 0 to t by 2 sine omega naught t into cos n omega naught t dt. So sine A cos B. The formula for sine A cos B is sine A cos B is equal to sine A plus B sine A plus B plus sine A minus B. The whole thing divided by 2. Right? It is divided by divided by 2. Now substitute the formula here in this one. This is my A and this is my B. So what will I get? I will get 4A by T integral 0 to T by 2 sine A plus B. What is sine A plus B? Sine 1 plus n omega naught T plus sine A minus B. Nothing but sine 1 minus n omega naught T dt. Right? So that is equal to, and we have divided by 2. So divided by 2. So what are we left with? 2a by t integral of sine is minus cos, right? So minus cos 1 plus n into omega naught. What is omega naught? Omega naught is 2 pi by t. Omega naught is 2 pi by t into t divided by 1 plus n into omega naught again minus cos 1 minus n omega naught is 2 pi by t into t divided by 1 minus n omega naught, and the limits are 0 to t by 2. Now this omega naught here and here, we can take it common. I'll take it outside. Okay, so what am I left with now? I can take this omega naught and this omega naught outside. So that will be omega naught here, right? Then that is equal to omega naught place. I can substitute 2 pi by t. So t gets cancelled, 2 gets cancelled. I have a by pi, and let me substitute the limits. So substitute t by 2 here. So t and 2 gets cancelled. I'm left with minus cos 1 plus n into pi divided by 1 plus n and t by 2, if I substitute here, I have t by 2, if I substitute here, I have cos 1 minus n, cos 1 minus n into pi again, divided by 1 minus n minus of in place of t, now I'll put 0. Cos 0 is 1, so minus 1 by 1 plus n minus, again cos 0 is 1, so 1 by 1 minus n, right? Now for n is equal to 1, when n is equal to 1, when n is equals to 1, this equation here, equation 1 does not hold, right? When n is equal to 1, what happens to equation 1 here? 1 minus 1 in the denominator. That means you're dividing by denominator is 0, you're dividing by 0, it is undefined, right? So when n is equal to 1, we will find the value of a1 separately. a1 we will find separately, right? a1, what happens to a1? a1 is equal to 4a by, here I'll substitute n is equal to 1. Okay, in this equation, at this level, I will substitute n equal to 1. It is 4a by 2 pi, 4a by 2 pi, 0 to t by 2, 0 to t by 2, sine n1. So I have sine n plus 1 is 2, sine 2 omega naught t, right? Sine 2 omega naught t. When n is equal to 1, this term goes to 0. So that's it. Now, if I simplify this further, if I integrate first, 4a by 2, sorry, it's not 2 pi here. It is 4a by 2t, right? By 2t. So, (2a by t). When I integrate sine, that is, I'll get minus cos 2 omega naught is nothing but 2 pi by t into t divided by 2 omega naught. The 2 omega naught, I'll take it outside, right? Instead of 2 instead of omega naught, I can write 2 pi by t, right? And my limits are 0 to t by 2. So 2 cancel, t cancel. I have a by 2 pi, with, if I put t by 2 in place of t by 2 and 2 by t gets cancelled. Cos 2 pi is nothing but cos 0. So cos 0 is 1. So minus 1 minus of cos 0 is 1. So again minus 1. So this a1 is equals to 0. Minus 1 plus 1 is 0. So a1 is 0. Then Again, we have to find for other values of n. So when n is equal to even, what will happen? When n is equal to odd, what will happen? We'll just check that now. So what happens when n is equal to even? When n is equal to even, my an will be equal to, what will happen? a by pi, a by pi, so even n. So 1 plus n will be odd, right? 1 plus n will be odd. So I can write it as 1 plus n will be odd. Cos odd into odd number into pi. So cos 1 pi or cos 3 pi or cos 5 pi. They're all -1. So -1. This tends to be -1. So -1 into -1 is +1 divided by 1 plus n when n is even, right? Then minus cos 1 minus n. This is also an odd number, right? 1 minus n. When n is even, 1 minus n is odd. 1 minus n is odd. So I have again 1 minus n, and here it is plus 1 by 1 plus n and plus 1 by 1 minus n. If I simplify this, 1 plus n plus 1 plus n, it is nothing but 2 by 1 plus n. So simplifying this further, I'll write it at the same place. Okay, I will combine these two here and write as 2 by n. Is 2 by 1 plus n, and these two I'm going to combine and write as 2 by 1 minus n. 2 by 1 minus n. Simplify it further, I will get 2 into 1 minus n. Okay, I'll take 2 common, so let me take 2 common. 2a by pi, and I'm left with 1 by 1 plus n plus 1 by 1 minus n. So let me take the LCM, that is 1 minus n square. A plus b into a minus b is a square minus b square. Here I have 1 minus n plus 1 plus n, and n gets cancelled here. So I have 2 here in the numerator, that is 4a by pi into 1 minus n square, right? That is my an when n is even. Now what happens when n is odd? When n is odd, an is equals to, when n is odd, 1 plus n is even. 1 plus n is even. So even number into pi. Even number into pi. So cos 2 pi or cos 4 pi, what will happen? Cos 2 pi, cos 4 pi, it's all 1. So I'll have a by pi minus 1 by 1 plus n. Similarly, this one is also, the numerator will become 1 minus 1 by 1 minus n, and I have plus 1 by 1 plus n plus 1 by 1 minus n. Everything gets cancelled here and it is equal to 0, right? It is equals to 0. It is equal to 0. So now I found out a naught. So what is my a naught? A naught is equal to 2a by pi, right? 2. Okay, a naught is equal to 2a by pi, right? And an is equal to, what is an? It is 4a by pi into 4a by pi into 1 minus n square, right? This is for n is equal to even, n is equal to even, and 0 for n is equal to odd. So 0 for n is equal to odd. A1 is also 0, right? For n is equal to odd, it is 0. Now what we'll do, we'll have to express x of t in terms of Fourier series. So let us express that. Now let us express x of t in terms of Fourier series. My x of t is equal to, what is a naught? A naught is 2a by pi plus summation n is equal to what do we have? We only have even numbers, right? For odd it is 0, so I can write n is equal to 2, 4, 6 and so on. My an is what? An is 4a by pi into 1 minus n square into cos n omega naught t, and my bn is already 0, so I don't have to write anything there. So I can expand this 2a by pi plus, when n is equal to 2, what happens? I'll get 4a by pi into n is equal to 2, 1 minus 2 square, it is minus 3, right? It is minus 3. So minus, in the numerator I have cos 2 omega naught t by 3, cos 2 omega naught t by 3. Then when n is equal to 4, I have 4a by pi is common, and in the numerator I have cos 4 omega naught t, cos 4 omega naught t divided by 1 minus 4 square, that is minus 15, minus 15 in the denominator, minus, and so on, right? This is my final answer. That's my final answer.